Welcome to ClickMyProject.com. Now we are going to discuss about the project Accuracy Enhancement of Hand Gesture Recognition using CNN. Now we are going to discuss about the abstract of the process. Human hand gestures are immensely significant in human-machine interactions systems. The complex hand gestures input and then the noises caused by the external environment must be addressed. In order to improve the accuracy of the hand gesture recognitions algorithm, we have to remove the noises as well as we have to improve the quality of the classifications. This nature requires different approaches from the different action recognitions to capturing the complex spatial features based on the local binary patterns algorithms. Hence, this is most commonly used algorithm to extract the patterns from the hand gestures regions. This will work well fine for the background as well as the foreground extractions of features. Many gestures categories have been very similar, hence when it is missions to the temporal patterns positions as well as challenging on the temporal processing. So to overcome these challenges, we employ the combination of the 2D FFT and then the convolutional neural network in this process to implement whether the hand gestures is 1, 2 or whatever it is. So we have to classify these ones based on the deep learning method. Finally, the performance of the process will be evaluated based on the accuracy and the error rate. Now we are going to discuss about the flow diagram of the process. This is the overall working flow of this project. This project consists the modules such as the input image, pre-processing, segmentation, feature extraction, classification, then finally the performance estimation. At first, the input image is taken from the dataset. The dataset consists of lots of hand gestures in the datasets. We have to took any one image from the dataset. After the user selected the input image from the dataset, the pre-processing will be carried out. In this pre-processing, one of the major step is the image resize, then the grayscale conversion. First of all, we have discussed about the image resize. Image resize is doing to resize the image into an aspect ratio of 256 cross 256, which means the number of row will be the 256, number of column will be the 256. The reason for image resizing is to maintain the aspect size of the image. After doing the pre-processing, the segmentation will be carried out. In this segmentation, we have to track the hand region as well as we have to extract the ROI extraction. ROI in the sense region of interest. The hand region is the region of interest. Other than the hand region, it will be considered as a background region. So we have to extract the hand region separately. The reason for extracting the hand region separately in the sense, the background images are also having the lots and lots of pixels. So we have to eliminate those pixels. Then we have to extract the required pixels alone. That is the reason we are extracting the hand region alone. Then finally, next to the segmentation, the feature extraction will be carried out. In this feature extraction, we are using the deep learning and then the local binary pattern along with the 2D FFT is used to extract the features from the gestures regions. So we are taking the features like CNN, LBP and 2D DFT. So we have to combine these three algorithms to generate the test features. After generating the test features, we have to import the train features also to the classification. The test feature is the features of the input image alone. The train feature is the features of the overall dataset. After importing the test and train features into one machine learning, the classification will recognize whether the given input gesture is whatever the gesture may be. So whether it is on 1, 2 or whatever it is. So after classifying this one, we have to do the performance estimation by means of the accuracy, error rate, sensitivity and specificity. Now we are going to discuss about the running procedure of the process. At first, open the Spider 3.7. After doing the opening, we have to change the current directory like this. After that, if you want to execute the file, just open the main file.py and then the code was open. You can click the run button. Once you click the run button, in that console you can see the images will be open. In that images you have to select any one image from the dataset. Once you have selected the image from the dataset, the corresponding actions and the results will be shown in the consoles. Now this is the original image which the user has taken as an input. After taking the input image, we just move to the pre-processing. In that pre-processing you can see the difference between the input image and then the size of the resized image. Now the size will be the around 300 something. Now here the size will be the around 200 something. So we have to resize the image before get into the processor. After that we have to do the channel separation like red, green and blue channel. Basically the color image having the three kinds of band, that is the red, green and blue. Here we have splitted the color bands separately, then it will be converted into one grayscale image. Once it was converted into one grayscale image, we just doing the segmentation of hand portions alone. Here the hand portion is segmented and then the other backgrounds will be completely eliminated. It will looks like a black color. The white pixels indicates the hand regions. After that the features will be splitted into an 80-20 ratio, which means the number of test data will be the 20%, number of trained data will be the 80%. After that we are going to extract the CNN features along with the FFT. So this is the layers we have assigned in the CNN features. Then the LBP is used to extract the patterns from the images. These are the results which are used in the LBP. So you can see the LBP results here, as well as the values of that feature extraction will be shown here. So this is the values we are obtained from the feature extraction. After doing this one, we have to recognize whether the action is 1, 2 or 3, whatever it is. So first of all we have to recognize the actions, and then the corresponding activity is displayed here. Here the corresponding activity is upwards, so it will be displayed here. Then finally the accuracy of the classification and then the error rate of the classification will be shown here. Now the accuracy of the classification is around 98%, 98.9%. Now the error rate of the classification is 1.0%.